this lecture we shall present a proof of a property that involves the image under an injective mapping. Recall that in a previous lecture we have established that for all sets A, B, S and T, with S and T subsets of A, and for all mappings F from A to B, we have that the difference of the images under F of S and T is included in the image under F of the difference of S and T. In another lecture, we've also established by means of a counterexample that the converse inclusion is not true in general. In this lecture, we shall prove that if we in addition assume that F is an injection, then the converse inclusion does hold. So we have that the image under F of the difference of S and T is included in the difference of the images under F of S and T. The condition of the conditional statement we are going to prove is put in a flag. Assuming that F is an injection, we need to derive that the image under F of the difference of S and T is in the difference of the image under F of S and the image under F of T. So we start with an application of the definition of subset, which gives rise to the declaration of an arbitrary element y in the image under F of the difference of S and T, for which we need to establish that it is also in the difference of the image under F of S and the image under F of T. We proceed with an application of the property of difference, according to which it suffices to establish a conjunction. The conjunction is, as usual, proved by establishing the two conjuncts separately. It remains to prove that y is not in the image under F of T, and that it is in the image under F of S. We now switch to forward reasoning to draw some conclusions about y. Y is an element of the image under F of the difference of S and T, so we apply one of the two properties of image, according to which there exists an element in the difference of S and T that is mapped to y. The witness for the existential quantification will be instrumental in establishing both goals. Note that X is an element of the difference of S and T. So, with an application of the property of difference, we get that X is in S and X is not in T. Now we can easily establish our second goal, which is to show that y is in the image of S under F. For we have an element X in S, of which we know that F maps it to y. From X in S we get, by the other property of image, that F of X is in the image under F of S. And then we may use that F of X equals y, to conclude that y is indeed in the image under F of S. It remains to establish the other goal. We do some backward reasoning first, applying the standard method for proving negations. We assume that y is in the image under F of T and derive a contradiction. Returning to forward reasoning mode, note that we may combine that F of X equals y with the generated assumption that y is in the image under F of T, to conclude that F of X is in the image under F of T. This seems to be the moment to use that F is an injection. For if F is an injection and F maps X into the image under F of T, then at least intuitively X is in T. And this would yield a contradiction with the assumption that X is not in T. It is convenient to formalize the intuitive idea by proving a lemma separately. So, for the moment we interrupt our current derivation to concentrate on proving a separate lemma. Let's clearly mark the place in our derivation that still requires an argument by leaving 3 vertical dots. The lemma that we shall prove states that whenever F is an injection, then X in A' is a logical consequence of the assumption that F of X is in the image under F of A'. Note that we get two assumptions, that F is an injection and that the F of X is in the image under F of A'. And then our goal is to establish that X is in A'. We cannot further simplify X in A', so we immediately switch to forward reasoning mode. On the assumption that F of X is in the image of A' under F, we can apply one of the two properties of image. Note how F of X takes the role of y in the property of image. Moreover, since there is already a variable x in our derivation, to avoid confusion, it is better to rename the bound variable in the existential quantification. We rename it to x'. We now have an x prime that is mapped by f to f of x. In other words, x prime and x are mapped to the same element by f. Hence, since f is an injection, we should be able to conclude that x prime and x must be equal. The property of injection for f states that for all x1 and x2 in the domain of f, if f of x1 equals f of x2, then x1 equals x2. We use it by doing a universal quantification elimination with x prime for x1 and x for x2. This yields an implication with f of x prime equals f of x as condition. Note that the condition is valid in the present context. So with an implication elimination, we get that x prime equals x. Hence, since x prime is in A prime, it follows that x is in A prime. Let's transform the derivation into a proof. The lemma is about sets A and B, a mapping f from A to B, an element x in A, and a subset A prime of A. It then states that if f is an injection, then from f of x in the image of A prime under f, we may conclude that x is in A prime. The proof starts with stating the two assumptions and the simplified goal, and it then first applies the property of image and subsequently the property of injection. You may want to pause the video to read the proof. Recall that we were in the middle of the derivation shown here when we entered a digression to prove a lemma separately. Let's now complete this derivation with an application of the lemma at the place of the vertical dots. Note that f is an injection, and f of x is in the image under f of t. So we can apply the lemma to conclude that x is in t. Since we also have that x is not in t, we get the contradiction that we were after. Our derivation is complete. Let's transform it into a proof. The proof first applies some backward reasoning to simplify the goal, generating the assumption that f is an injection and a declaration of some y in the image under f of the difference of s and t. We then need to establish that y is in the image under f of s and not in the image under f of t. In forward reasoning mode, the properties of image and difference are used to conclude that there exists an x that is in S but not in T, such that f of x equals y. The property of image allows us to conclude from x in S that y is in the image under f of s. The lemma, which we have proved separately, allows us to derive a contradiction from the assumption that y is also in the image under f of t. Note that it is essential for the application of the lemma that f is an injection. Here you see the full proof. You probably want to pause the video to read it. We have established in this lecture that if f is an injection, then the image under f of the difference of s and t is included in the difference of the images under f of s and t. And we have shown also at the beginning of this lecture that the property does not hold in general without the requirement that f is an injection. This concludes our discussion of an example involving the notions of image and injectivity.